Good afternoon, everyone present here. I am Nandini T. I am working as an assistant professor in the SNS College of Technology, the Department of Computer Science and Technology. Today we are going to see case study with video with our students on the topic generative models. There are many generative models we use like GAN, Gaussian mixture model, hidden Markov model, autoencoders, diffusion models likewise. So we will be explaining one by one by our students.
Hi, I am Danish. I am going to tell about introduction and GAN. Generative models are a class of machine learning models designed to generate new data samples that resembles a given data set. They learn patterns, structures, and distributions rather than just predicting labels. One of the most popular generative model is the Generative Adversarial Networks, GAN. GAN consists of two neural networks, a generator which creates fake data and a discriminator which evaluate whether the data is real or fake. These two networks compete against each other, improving literally. GAN are widely used in image synthesis, deepfake generation, super resolution, and artistic content creation.
So why are GANs called adversarial models?
GANs are called adversarial because two networks, generator and discriminators, are trained in opposition. The generator tries to fool the discriminator with fake data, while the discriminator tries to correctly distinguish field from fake. The competition helps both network improve.
Thank you.
Next generative model is a variational autoencoder. A variational autoencoder is another generative model that learns a compressed representation of data called the latent space. Unlike traditional autoencoders, VAEs treat latent variables probabilistically. The encoder maps input data into a probability distribution, and the decoder samples from this distribution to reconstruct or generate new data. VAEs are stable to train compared to GANs and are commonly used in anomaly detection, image generation, and data interpolation. They are particularly useful when smooth transition between generated samples are needed.
So how does a VAN differ from a normal autoencoder?
A normal autoencoder produces a fixed latent vector where a VAE learns a probability distribution. This allows VAEs to generate new variations of data by sampling from the latent space.
So the next model is Gaussian mixture model. The Gaussian mixture model is a probabilistic generative model that assumes data is generated from multiple Gaussian distribution. Each Gaussian component represents a cluster or a subgroup within the data. The GMMs are used for density estimation, clustering, and data generation. Unlike neural generation model, GMMs are simple and mathematically interpretable. They are applied in speech recognition, customer segmentation, and pattern recognition, where understanding data distribution is important.
Why we use multiple Gaussian instead of any other generative models?
The real-world data is often complex and multimodal. A single Gaussian cannot capture multiple pearls and clusters, but multiple Gaussians can model diverse patterns within.
Myself, Sricharan, I am here to explain about hidden Markov model. Hidden Markov model is a generative model used for sequential on-time series data. It assumes that observations are generated from hidden states that follow a Markov process. HMMs are widely used in speech recognition, handwriting recognition, bioinformatics, and activity recognition. The model captures temporal dependencies and transitions between hidden states, making it suitable for problems where data evolves over time.
So what makes the HMM suitable for sequential data?
HMM explicitly model state transition over time, capturing dependencies between future and past observations, which is essential for sequential patterns like speech and gestures.
Diffusion model and conclusion. Diffusion model are modern generative models that generate data by gradually adding noise to training data and then learning to reverse this noise process. They have recently gained popularity for high quality image generation and are used in AR, design and content creation. Compared to GANs, diffusion model produce more stable and diverse outputs but could require more computation. In conclusion, different generative models serve different purposes. GANs excel in realism, VAE provide structured land expression, GMFs offer probabilistic simplicity, HMM handles sequential data, and diffusion models deliver high quality synthesis. Choosing the right model depends on the application and data type.
Why are diffusion models considered powerful today?
Diffusion model produce highly realistic and diverse outputs with stable training, making them superior for tasks like image synthesis despite higher computational cost.
Thank you, students. It will be very helpful for us by seeing these 5 types of generative models. Thank you.